In this demonstration, I'll show you how to find the area between two curves using integrals. The area between the curves y is equal to f of x and y is equal to g of x, and the lines x is equal to a and x is equal to b, where b and g are continuous, is shown below. Essentially what you do is you subtract the two functions and then you integrate at the lower and upper limit. Let's get started with question number 1. In this question, they're asking us to find the area bounded by the curves y is equal to the square root of x and y is equal to 1, and between the lines x is equal to 1 and x is equal to 7. Now you'll see that this red curve here represents y is equal to the square root of x, and this blue curve here represents y is equal to 1. What's not shown here is x is equal to 1, which is essentially a vertical line from 1 going upwards, and a line from 7 going upwards. So essentially what they want is they want us to find the area of this. What we can derive from this diagram is the lower and upper limit. So what I'll do is I'll use this relationship here, and my a will be 1 and my b will be 7. So we'll integrate between 1 and 7 for the function the square root of x minus 1 dx. The next step will be to find the antiderivative of this term and of this term separately. So this right here is our f at x, and this right here is our g of x. So we'll start off with our f at x. We'll find the antiderivative. X to the power of half becomes x to the power of 3 over 2. I added 1 to half over 3 over 2. And this becomes 2 times x to the power of 3 over 2 over 3. Similarly, I'll find out what the antiderivative of 1 is. The antiderivative of 1 is x. Next, I will subtract this function with this function and then evaluate that end function at 7 and 1. Here's what I mean. 2x to the power of 3 over 2 over 3 minus x will be evaluated at x is equal to 7 and x is equal to 1. Let's start off at x is equal to 1. 2 times 7 to the power of 3 over 2 divided by 3 minus 7. We end up with 5.34. So let's write that down. And we're going to subtract that by what this function gives us when we evaluated it at 1. 2 times 1 to the power of 3 over 2 gives us negative 1/3. So now I'll go ahead and subtract these, minus my answer gives me 5.67. So the area in between here is 5.67 units squared. Let's proceed on to question 2. In question number 2, they ask us to find the area enclosed by y is equal to 5 minus 2x and y is equal to 4x minus x squared. This red curve here represents y is equal to 5 minus 2x, and this green curve here represents 4x minus x squared. So we're going to call this function f at x, and we're going to call this function g at x. And what we're looking to find is the area in between. The difference between this question and the previous question was that in the previous question they were a lot more explicit. They told us exactly the lower and the upper limit. Unfortunately, in this question they don't. So if you ever run into a situation like this, you have to find out where they intersect. And the way you find that is you make the two equations equal to one another and find the x's then. So 4x minus x squared is equal to 5 minus 2x. And what we're going to do is solve for x. We're going to bring all the terms over, this term and this term, where we have negative x squared plus 4x minus 5 plus 2x is equal to 0. The 4 and the 2 add up to 6x. minus x squared plus 6x minus 5. And at this point, I'm going to multiply both sides by -1 because I don't like to have a leading negative coefficient. And if I do that, I end up with x squared. You'll notice that this is a quadratic equation, so you'll need to use either the quadratic formula to find your x's, or if it's factorable, you can find it out that way. And you'll notice that this 5, if you multiply -5 and -1, it multiplies to 5 and adds to -6. So those are our factors. X minus 5, x minus 1 is equal to 0. Therefore, x is equal to 5 and x is equal to 1. So that's the points in which they intersect. Those will effectively be your lower and upper limit. So let's go ahead and continue on with this question. We have the integral between 1 and 5, f at x minus g at x. And our function was, for f, 5 minus 2x minus our function 4x minus x squared. And don't forget, we're integrating this. So use this symbol. The next step will be to multiply this out. We want to expand. And if we do that, we have 5 minus 2x minus 4x plus x to the power of 2. And what we're going to do is find the antiderivative of each of these terms. X to the power of 2 is x to the power of 3 over 3. And now we're going to evaluate this at 5 and 1. So we'll start off with 5, and we're going to use our calculator to speed this up. 5 times 5 minus divided by 3 gives us negative 25 over 3. Negative 25 over 3. We're going to do the exact same thing for 1. We're going to use our calculator once again. Divided by 3 gives us 7 over 3. We will subtract these. The denominators are the same, so we're going to keep the denominator the same at 3. Negative 25 minus 7 is equal to negative 33. And there you have it, the answer. Let's proceed on to the next question. In the last question, they ask us to find the area enclosed by y is equal to x and y is equal to x to the power of 3. Now, like in the previous example, we will need to find the points of intersection so that we can find the area that represents this. We'll start with that. X to the power of 3 is equal to x. Next, we'll take this x and bring it over. X to the power of 3 minus x is equal to 0. I'm going to factor out an x. X to the power of 2 minus 1 is equal to 0. This suggests that one of our x's is equal to 0. And if we divide both sides by x's here, we end up with x squared minus 1 is equal to 0. And this effectively will give us plus minus 1. And I'll write down x is equal to negative 1 and x is equal to 1. Now what this suggests is that we'll need to integrate between negative 1 and 0, and then again between 0 and 1. So let's do that. We have to integrate between negative 1 and 0 for the same function. And also, you'll need to integrate from 0 to positive 1 for the following. So let's go ahead and find the antiderivatives of the first function and the second function. This, let's call f at x, and we're going to call this right here g at x. So f at x is equal to x to the power of 3. We're going to take the antiderivative of this. We end up with x to the power of 4 over 4. And similarly, the antiderivative of x is equal to x to the power of 2 over 2. That said, we can now evaluate them at these limits. X to the power of 4 over 4 minus x to the power of 2 over 2. And if we evaluate this at 0, we end up with 0. And if we evaluate this at negative 1, we end up with negative 1 to the power of 4 is positive 1, so we have a quarter. And here we have a half, so a quarter minus a half gives us a negative quarter. So this number right here represents the answer for that. But also keep in mind that we are taking the absolute, so it would be a positive quarter. Now, keep in mind that since our function is symmetrical, and we found the area of this to be a quarter, we can assume that the area of this will be a quarter since it's essentially the same thing. So instead of going ahead and doing all of this, we can use our common sense and say a quarter plus another quarter gives us a half. And that is the area that represents what's enclosed by these two functions. So there you have it. 3 examples on how to find the area enclosed within 2 separate functions. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.